How can I help you, sir?
Yes, I'd love a smoothie, please.
Yes, of course.
Thank you very much. So, this talk is about love of food and drink. I love food and drink. Who doesn't? And as well as being vital to keep us alive, it's also central to the social activities that we get involved in, from a romantic dinner for two, I think these are real, to drinks after the theatre. So it's a really important part of life, and it's all about the love. What it's got to do with mechanics is that it's one of those processes that we just take for granted, but it's actually a very complicated biomechanical process. To take something and swallow it, you've got to change its mechanical properties, lubricate it, and squeeze it and pass it back safely past the airways, down through the esophagus into the stomach. Now, for 1 in 12 people around the world, there's some part of that process that doesn't work so well. And that could be a premature baby who's having difficulties learning how to drink milk, or it could be through the lifespan, people with Down syndrome, cerebral palsy. 80% of people who have Alzheimer's are going to be infected by their swallowing disorders. So on the left here, we see an example of something going wrong with swallowing. Most of that liquid's going down into the stomach, but some of it's going into the lungs. And if that person hasn't got the strength to cough it back up again, it will sit there and it could get infected. And that could cause aspiration pneumonia, which could be fatal. In these cases, changing the mechanical properties of that fluid can actually help. If the fluid's thicker, it flows more slowly and gives them more time to swallow. But it can also go wrong the other way. If it's too thick and sticky, then a piece of food can become lodged in the throat and choke somebody to death, and that's unfortunately what happened here. So it's quite a vital part of our lives, and something where mechanical engineering has potential to make a positive impact. Now imagine a sort of nursing home scenario. If you're healthy and just enjoying life, then you can participate in eating and drinking and socializing with your friends, as it should. But if you do have some problem with your swallowing, then you might not be able to take part in that. And if you're not confident that you can eat or drink properly and safely, and if you get served something like this, some nice dry, hard chips, well, there's nothing you can do with that. You'll just sit there looking at it, and as well as missing your lunch, you're missing out on that social interaction. It's very depressing. Fortunately, there's a lot that mechanical engineering can do by changing the textural and fluid properties of materials. In molecular gastronomy as well, we see lots of examples of the way that you can precisely control the textures of foods and drinks. The question is, how do those textures relate to the biomechanics of swallowing? In Mech-Eng, we've done lots of research on this, and we can measure very precisely the fluid characteristics of drinks and textures of foods. And we've created an oral simulator, and this is thanks to Dr. Andrew Redfern, who's just got his PhD on this work, so that's great. And the simulator that you see here models a compressive wave of the tongue, and it's got particle tracking and pressure sensors so that we can see and feel what goes on in the mouth. And all of this is very good for understanding how foods and drinks relate to swallowing. But that's no good unless it actually gets out there to help real people in the real world. And that's where I got involved with an international organization to standardize foods and drinks in healthcare across the world. They tasked me with creating tools and measurements that could replicate all of these expensive and complicated tests in a way that anybody could use and for minimal cost. So to do something that simple is actually very complicated. And I do have with me here my rheometer, 10 pence worth. We studied the flow of all sorts of complicated non-Newtonian drinks through this because we needed to be able to reflect things from chicken soup through to thick smoothies. And we found a tool that you can use. You take 10 milliliters of your drink, time the flow through this for 10 seconds, and the amount that remains is what we're using as an indicator of the fluid thickness. And this is being adopted all around the world and in the UK at the moment as the standards for texture modification for drinks in healthcare. So if somebody's safety depends on the consistency of their drink, they know they're going to get the right level. So this is really nice that it's being used all through the NHS and in medical conferences. And it's the same technique that's being used in the best hospitals in North America and in very underdeveloped rural areas of South Africa. And you can always, you can even use it at kids' parties. So with these set of standards for foods and drinks, that's inspired the creation of some really nice products that people actually want to eat and drink. And we have an expo on Monday just around the corner where we're showing off this with clinical presentations from healthcare back to back with cookery demonstrations. So with a bit of engineering and a bit of love, and food doesn't need to hurt.
Here you are, sir.
Thank you very much. Is that level 2?
Yes, of course it is.
Perfect.
Enjoy.
So if I had swallowing disorders, I would know then that this is the same standard that I can cope with, and I could drink it safely. Just need to wait for my date to turn up. Cheers.